This is the last lecture in the series of logical operators in propositional logic, and in this particular lecture we are going to talk about the biconditional operator. Now let's consider the definition of biconditional operator. Let P and Q be two propositions. The biconditional statement of the form P biconditional operator Q is the proposition P if and only if Q. Please note down this point that this is the symbol we are going to use for biconditional operator, and a biconditional statement looks like P if and only if Q. Why it is called biconditional? As the name itself suggests, it is the combination of two conditional statements. That is, P implies Q and Q implies P. If you remember the conditional operator, that is implication operator, we know that in the case of conditional operator, it is P implies Q. In the case of biconditional operator, it is P implies Q and Q implies P. As simple as that. Now, P if and only if Q is true whenever the truth values of P and Q are same. Let's consider the truth table in order to understand this point in a better way. Now, when truth values of P and Q are same, then only we would be able to get the compound proposition true, as you can see from this truth table. That is, when P is true, Q is true, then we will get the compound proposition true. And when P is false, Q is false, then also we will get the compound proposition true. Otherwise, the compound proposition is simply false. Now, why it is the case? Biconditional simply means not only P is sufficient for Q, but P is necessary for Q as well. Therefore, we can say that when P is true, then Q has to be true. And when P is false, then Q has to be false. Similarly, we can also say that when Q is true, then P has to be true. And when Q is false, then P has to be false. That is the reason why only for these two combinations we have the compound proposition true. Okay? Now let's consider one question. How P if and only if Q makes sense? Now let's try to understand why we are writing if and only if in between P and Q to indicate the biconditional statement. Let's try to understand this particular point. P if and only if Q is composed of two statements. P if Q and P only if Q. Isn't that so? It is the combination of these two statements, P if Q and P only if Q. Now let's try to understand them separately. P only if Q simply means if P then Q, and P if Q is equivalent to if Q then P. Isn't that so? Now, because a biconditional statement is the combination of if P then Q and if Q then P, it looks like P implies Q and Q implies P. We can combine them together to represent this particular compound proposition, that is P biconditional operator Q. This biconditional operator comes from these two implication operators, that is forward arrow from P to Q and backward arrow from Q to P. Now let's consider the different ways to represent the biconditional statement. Not only we can say that P if and only if Q, but we can also say that P is necessary and sufficient for Q, and we can also say that Q is necessary and sufficient for P, right? If P then Q and conversely is also one of the representation of biconditional statement. P if and only if Q can also be written in short form as P if Q. Please note down, it is not if, it is if. It represents if and only if. Let's consider one example in order to understand how we can write biconditional statements if we have two propositions P and Q. Let P be a proposition, you get promoted, and let Q be a proposition, you have connections. Then, P if and only if Q is the statement, you get promoted if and only if you have connections. As simple as that. Now, this particular compound proposition is true whenever P is true and Q is true, or whenever P is false and Q is false. You get promoted if it is true, and you have connections, if it is true, then definitely this compound proposition is true. If you haven't get promoted and if you have no connections, then also this compound proposition is true. Here if you get promoted but you have no connections, then this compound proposition is false, because according to the statement you get promoted if and only if you have connections. Now you get promoted and you have no connections, then definitely this compound proposition is false. And suppose if you haven't get promoted and you have connections, then also this compound proposition is false. Now it's time for the homework problem. Write each of the following propositions in of the form P if and only if Q. If you read newspaper every day, you will be informed, and conversely. It rains if it is a weekend day, and it is a weekend day if it rains. The trains run late on exactly those days when I take it. For you to get an A in this course, it is necessary and sufficient that you learn how to solve discrete mathematics problems. You can always post your answers in the comment section below. Okay friends, this is it for now. Thank you for watching this lecture.